We are now going to discuss the domain name system, also known as DNS. It is used every time that you visit a website. So it is widely used all over the world. So the problem is that as humans, we can only remember human readable names such as google.com. We cannot remember the IP addresses. However, the network infrastructure needs IP addresses. So if you want to go to google.com, you need to specify a destination IP address. So there is this dichotomy. As humans, we can only remember human readable names, whereas the infrastructure, it needs IP addresses. So the DNS system comes to our rescue and helps us convert names to IP addresses. Now, DNS messages are always sent using the UDP protocol to avoid the TCP overhead. As you can imagine, there are millions of users around the world who are accessing websites all the time. And every time you access a website, the DNS translation needs to be done. So there are billions of DNS translations being done every minute. Now, we don't want to use TCP because it creates separate connections to the DNS server and then it resolves the name. We use the UDP protocol, which is very fast and which does not require connections and which does not require retransmissions. So in order to be more efficient, we use UDP for DNS resolution. However, there is a small catch. As you know, we already discussed that UDP is an unreliable protocol and it can result in lost messages. So what happens if you send a DNS request and it gets lost? Well, it's not a big issue because it is simply retransmitted. You can simply retransmit the request again and eventually get the name resolved. This is still far better than using TCP just for the reliability because TCP creates enormous overhead. And with millions and billions of DNS translations done every minute, we don't want that extra overhead. Now let's see how the DNS actually operates. So let's say you are a user sitting on your system and you want to go to google.com. Now the IP address of this domain is 100.12.13.22, but you don't know that and your browser doesn't know that. You only know google.com. So what you do is that you send a request, a DNS request message asking for the IP address of google.com. Now the DNS servers, they have these tables in which they have the mapping between the human readable name and the corresponding IP address. So what the DNS server does is that it sends you back the IP address of the domain in the DNS reply. And once you have the IP address, you can start communicating with the domain by putting it as the destination IP address. So this is how the DNS operates. The problem with the DNS servers is that you cannot have one single DNS server which caters to DNS resolution requests all across the world, because it will be a single point of failure and the load would be tremendous. So what we do is that we create a hierarchy of DNS servers so that the job is distributed among multiple servers. And secondly, we distribute DNS servers geographically across the world. For example, if you're sitting in Australia and you want to resolve a domain name, it doesn't make sense to send your DNS request to a server in the US. So that's why we have DNS servers which are spread throughout the world to distribute the load. So the first level of the DNS servers is called the root DNS servers. There are just 13 of these in the world and they contain a list of top level domain servers. So what are top level domain servers? A top level domain servers caters to a specific domain. So for example, a .com top level domain server which will handle all the DNS resolution requests which have .com at the end. We have hundreds of these and they are also spread throughout the world. For the root DNS servers, it should be noted that there are just 13 of these, and if somehow they come down, then the internet won't be functional anymore, because the websites would still be there, but the DNS translation would not be done. So there will be no way to get the IP addresses. At the third level, we have authoritative servers which have the specific IPs of the domains, for example abc.com. So in this way, we have a hierarchy of servers, and each of these servers, for example, the root DNS servers, top level domain servers, and authoritative servers are also distributed geographically around the world to spread the load around. Let's see how the DNS system actually operates. At the top level, we have the root DNS servers. Beneath them, we have the top level domain servers, which cater to specific domains such as edu, net, or com. And at the bottom level, we have authoritative servers which cater to specific domain names such as yahoo.com. So now let's say you want to go to stanford.edu. So what you're going to do is that you're going to craft a DNS request message and send it to the root DNS server asking for the IP of stanford.edu. Now the root DNS server has the list of top level domain servers and it is going to direct you towards the top level domain server for edu domains. So now you go to the top level domain server for the edu domain and ask the same question that I need the IP address for stanford.edu. Now the top level domain server is going to refer you to the authoritative server which caters to stanford.edu. And then you go to this authoritative server which finally gives you the actual IP address of going to stanford.edu. So this is how the DNS servers are arranged in an hierarchy, and also they're spread geographically around the world in order to load balance. So this concludes our lecture. I'll see you in the next lecture.